Good morning, class. Coach Jackson here to talk about the inverse of functions. Inverse of function can basically reverse what the function does. So if you take all the x's and y's of a function, the inverse will reverse them, switch them. So all the x's become the y's, all the y's become the x's. Well, that means that if f of x and g of x are inverses of each other, then if I did f of g of x and it equals x, and g of f of x, it should equal x. So we could then write these two functions as f of x and f to the negative 1 of x. This is what you would write for the inverse. Anytime you see that negative 1, that's the inverse. So let's look at an example. I have f of x equals x plus 2 and g of x equals x minus 2. So I want to look at the combination of these, plugging one into the other. Okay? So if I take x minus 2 and I plug it in where x is, I'm going to get x when I do the math. If I take x plus 2 and I plug it where the x is in g of x, and I do the math, I get x. That proves that these two functions are inverses of each other. When you do the composition of the functions both ways, and you get x for each one, that's the proof that they're inverses. When we graph inverses, since the inverse reverses all the x and the y's of the function, the graph of the inverse will be a reflection in the line y equals x. The line y equals x is the diagonal slope of 1. And I'll draw that in here. This is the line y equals x. So if I want the graph of the inverse of x squared, I know it's going to be plus or minus square root of x. It's just going to flip over that blue dotted line. Okay. This is a reflection in the line y equals x. So if you can graph two functions and see that they're reflective over the line y equals x, that's proof that they're inverses of each other. Here's another example. X cubed and the cube root of x. They would be inverses of each other because they're reflective over the line y equals x. We can also use the vertical line test to tell whether or not a graph is a function. And because an inverse function is flipped, we use the horizontal line test to tell whether the inverse is a function or not. So in this one, we all know x squared should be a function. Well, the inverse horizontal line test, it passes the horizontal line test, so the inverse is a function. Same would go for x cubed. So to find an inverse algebraically, here's the main part. To find an inverse algebraically, we want to replace the f of x with a y. We want to switch our x and y and solve for the y. And then in the end, we're going to replace it with f of negative 1 of x. So change the f of x to a y. Okay. We're going to switch the x and the y. So the y becomes the x becomes the y. And then we're going to solve for the y. So that means I got to get rid of everything on that side with the y. How do I get rid of a cube root? I cube both sides. How do I get rid of a -5? I add 5 to both sides. And then I replace that y with f -1 of x. And that's my inverse. To check your answer, you can graph both, see if they're reflective along the line y equals x. You could also do the composition of functions, plug one into the other, and see if they equal x. Next example. Replace f of x with y. Substitute or switch. This becomes a y, this becomes a y, that becomes an x. I'm going to have to cross multiply. So this is really over 1. So x times that and 1 times that. If I do the distribution property, x times y, x times 2, I get this. Well, there's only one problem with that. I've got mixed variables on one side of the equation there. So what we need to do to fix that is I'm going to get all of my y's on one side, everything else is on the other side. So I moved my 2x over by subtracting. I moved my y over by subtracting it, and I'm now down to this equation. Now what I can do is I can factor out a y. If I factor out a y, I've got x minus 1 left. And I can divide by x minus 1 to get y by itself. And I replace that y with f of -1 of x to get my inverse. All right. That concludes inverses. Let me know if you have any questions by emailing me or contacting me through the Zoom. Thanks. Have a good day.